Hello everyone. Today my tutorial is about language integrated query LinQ. I have to give you your assignment 2. And assignment 2 is nothing but replication of whatever we are doing in Visual Studio, but for your own product line. You can change your database accordingly and you can add your creativity and layout. So in my next week's lecture, I will talk about ASP Razor. Today I'm going to talk about LinQ because this is what I have used in my lab, and I want you guys to actually know what you are doing instead of just copy and pasting whatever is in that lab. So there are many things that you should know. So today we are going to talk about language integrated query. Now, LinQ is Microsoft's technology to provide a language support mechanism for querying data of all types. So these types could be your arrays, your collections, databases, XML documents. Why we need it? So we cannot programmatically interact with the database at a native language level. Usually what used to happen is that we used to connect with the database and then we used to get the data from the database, and any errors that were at the database level were not able to be diagnosed. So therefore this language integrated query actually indicates that the query is an integrated feature of any programming language, and therefore they're giving us rich metadata, they're giving us compile time, syntax checking, and IntelliSense, static typing. So they're actually integrated into our coding, and that's why we have IntelliSense with them. So that is why we want LinQ. So queries integrated into language, as I said, gone are the days of writing an SQL query into a string and not detecting a syntax error until runtime. That's what used to happen. And if you forget the name of the field of the table, you cannot actually detect what the error was. LinQ is an API. It's a collection of extension methods for classes, and the classes interfaces that it implements are IEnumerable and IQueryable. The namespace that we have to use when we are using LinQ is system.linq, and the two main classes that it has and that have other extension methods are enumerable and queryable. You have seen in the previous slide that you can have different types of LinQ to objects, LinQ to XML, LinQ to dataset, LinQ to SQL, and then LinQ to entities. And we are at this one at the moment. What is enumerable? Enumerable class includes extension methods for the classes that implement IEnumerable interface. Now, IEnumerable T means that there is a type coming in here. Any class, type, whatever. This is IEnumerable. Suppose it comes here. This includes all the collection types in. And then system.collections or generic is used for namespaces such as list, dictionary, sorted list, queue, hash set, and linked list. They're all types that can be implemented using IEnumerable interface. Variable class includes extension methods for classes that implement IQueryable interface. IQueryable is used to provide querying capabilities. So for example, Entity Framework API implements IQueryable to support LinQ queries with underlying database like SQL Server. LinQ return queries, they return a set of matching objects, a single object, there could be a subset of fields. And in LinQ, this returned set of objects called a sequence. And most LinQ sequences are of type IEnumerable, as we said earlier. All LinQ queries consist of 3 actions. So first they obtain the data source, then they create the query, and then they execute the query. Okay, so creating the query and executing the query are 2 steps. In this example, you have 3 parts of a LinQ query. One is the data source. It is just an array. Okay, int array with some numbers. And then you have query creation, where variable num query is equal to from num in numbers, where num mod 2 is equal to 0, select num. So you are actually creating a query, and then you are executing the query. So query is not executed here, but it executes here when you throw the values that you receive using for each. Okay, so the output should be, you can think about it and then I'll come back to it. So there is a data source, there is a query, and then query execution. So query has from, where, select syntax. And then for this query, which you stored in, num query here, from this query, you return each item and do something with that item and then get to next item. So this is how this LinQ query works. If the data source is an array, it implicitly supports generic IEnumerable interface, such as in our previous example. This implicitly supports IEnumerable interface. Otherwise, we declare it, and you have been declaring it in your lab assignment. When you declare your class product index view model, it has iQueryable and then IEnumerable collections, with one as product and then other is cats with count. So that's what you are declaring, and then you use them when you have to execute that query. So the data source. So data source is an array. It implicitly supports generic IEnumerable interface. That means it can be queried with LinQ. Anything that can be that can support enumerable or queryable, it can be queried with LinQ. A query is executed in a for each statement. That's what I'm telling you again and again. Types that support in IEnumerable or a derived interface, such as generic iQueryable, are called queryable types. So here, product is a queryable type. A queryable type requires no modification or special treatment to serve as a LinQ data source. Then with LinQ to SQL, you first create an object relation mapping at design time, either manually or by using LinQ to SQL tools. You then write your queries against objects and at runtime. And the example here, for example, this one, you have Northwind database. You created a Northwind database in this database object, and then you are querying customer. Now, customer is a type, and it is a table in your database. In cust query, you are resulting. Now, cust query is a query, and in this query, you have cust in table customer, where cust.city is equal to London, and then you select that cust. So this is creation of query. You are not executing the query, but you are creating a query. A LinQ data source is any object that supports a generic IEnumerable interface or an interface that inherits from it. So the query specifies what information to retrieve from the data source. Option, it also specifies how the information should be sorted, grouped, and shaped. So you have seen in lab assignment, you have seen this code which says from matching products and products, where matching products.cref id is not equal to null. Now, where is a condition, and then it says group matching products by matching products.category.name into category cat group. Now, group is something that you are doing before you're shaping the query before it is returned. Okay. Now in cat group.key, key is an extension method which returns the first name, first letter, then you're returning cat group.count. A query is stored in query variable and initialized with a query expression. To make it easier to write queries, C# has introduced a new query syntax. Now people who are working with SQL for very long, they might not like it, but it is supposed to be easier. It says it has 3 clauses, just like SQL, but the order is different. From specifies the data source, where applies the filter, select specifies the type of the return elements. So it is important to note that in LinQ, the query variable itself takes no action, returns no data. So as I said, it doesn't execute when we are creating the query. It only stores information that is required to produce the results when the query is executed at some point later. Okay. Now, this is also known as deferred execution. So, it means that actual execution is deferred until you iterate over the query variable in a for each statement. Or you can force immediate execution, and that is when you are using any aggregate function. In aggregate functions, you have count, max, average, first. They can be executed, but if you note, these are not collections. They just return a single value. And in your on your page 7, if you look at your view model.cats with count, it has um, count, cat group dot count. So cat group dot count is returning a single value in product count. Similarly, category name, cat group dot key is returning a single value in category name, right? So this is what forcing immediate execution is. So you select something and you force it to execute at the same time. Now, in this one again, this example, you can see that there is a variable query from num in numbers, where num is this. It is the same example that we did earlier. The output was 0246. So it doesn't execute here, but if you try to write a variable even num count and you do even num query dot count, it will return count of the numbers that you had in execution, which was 4. So to force immediate execution of any query and cache its results, you can call the list or toArray method. So here you have list in num2 from num in numbers, with num mod 2 is this toList. So you can have toList. You are adding everything that you got into num query 2 as a list or as an array. Yeah, so you can force execution by putting for each loop immediately after the query expression. However, by calling to list or to array, you can all cache all the data in a single collection object. So that's why it is preferable. Now, at the moment, we are at C# 3.0. In C# 1.0, what used to happen is that we had a class with these attributes, and we can, have these data. Then we had to traverse each of these to get the student whose age is greater than 12 and less than 20. Okay, and then we used to list them, and this is the loop that's working here. Anyway, so this was the program that we used to write in C# 1.0 with our data source. But then with 2.0, we had delegate, and this delegate, we can declare it and we can use it in our program to return the same thing. But it was kind of an extension where student array will check, and student array will go as an input, and then delegate student ID was checked to find any student whose age is greater than 12 and less than 20. So you can have different criterias. It was a bit easier, but with 3. We reduced the extension method, the lambda expression, expression T, anonymous type, and query expressions. They're building blocks of link to query to the different types of collection and get the resulted elements in a single statement. So for example, in this type of array, what is happening here, we are creating a link query expression, method syntax. This is known as method syntax. It is not query syntax. There are two types of syntax that LinQ supports. One is query syntax and one is method syntax. So this one is a method syntax where this is equal to, with angle bracket, is lambda. And what lambda does, it is an expression referred to as refers to an anonymous method with left side as input to the method. So this is an input to the method and right side as the output. So this is the output. So we're saying that s.age is greater than 12 and s.age is less than 20 goes into s, and we have to array that. We have to make an array of teenager students. Similarly here, now lambda has made writing expression easily. So we can find teenager students. To find first student whose name is Bill, we'll write, s dot student name is equal to Bill, and then dot first or default. Now this extension method just brings the first Bill or default, and then student 5, if student ID is equal to 5, first or default. If you do only first, it will throw an exception. Right. So in summary, we use system.links namespace to use LinQ. LinQ API includes two main static classes, enumerable and queryable. The static enumerable class includes extension methods. There are other things that are there. And with this, I added a hands-on work in tutorial. So you just need to understand the following code and write the output. And I also told them how to run these simple programs through Visual Studio console application. So what you do, you go to your Visual Studio, you go to new and then project and go to just C# and console application, core framework, blah blah blah. I just want a blank application. If there is no blank application or it doesn't say anything else, so just say console application.net framework and then make it. So it will create a program for you with a main. So why I want you guys to do it, because there is some code that I want you guys to work with. For example, I want you guys to know your LinQ queries well, so that when you are doing your own project, you are able to create your own queries, right? And this is very good work through. See if I can find it and show it to you. So you can walk through writing these queries, and it is telling you how to do it. See, it's console application. Just check. So for example, if you want to try this, class student. Okay. Now you have this data source. You have your main. Main is where your data, your work starts from, and you have this class in your project. So you have two classes now. One is name and one is program and one is student. So for example, they are telling you how to create the query. Simple queries, they're telling you, for example, this, and then execute the query. So what I'll do, I'll just create this query in my main. So this is IEnumerable query, student query from student and students, where student dot square 0, score 0 is greater than 90, and select student. Now this is just, so this is data source, this is creating query, and then executing the query. So for executing, you just do this, write the query, and it will create, the 0 means student dot last and 1 is student dot first. So you just create that and build it and debug. So open up the console window and it'll give you the result. So why I want you to do these, so that you know how these queries result in the answers that you want. So try this. So I think that's all. Thank you guys. Have a good evening, night, morning, wherever you are. Bye.